This video builds on the previous video about a unit circle, and you might know now that trig is not just about triangles, but it's also about circles. And what I'm showing you is just a little part of the Maths is Fun website, because they've got the unit circle that we're familiar with here, as you know, is a radius of 1 and a center at the origin 0, 0. But you can see that it actually can be used to generate a function, a graph. So you can see as the radius arm, now that's in grey there, you can see the cursor going up and down the radius arm, and as it starts, let's start the unit circle at 0 degrees. Radius arm's going in its anti-clockwise direction, which is the positive direction. You can see the green zone getting longer and the blue zone getting shorter. Now it's important to remember that, and when we get to the top it's all green and there's no blue, and we've got a right angle, and the green's getting shorter, the blue's getting longer. The blue's negative because it's the x direction. Now the green is negative, so is the blue. And now the green is still negative and the blue is positive, and we get right around. Now also notice the wave that it in the right, the wave that it produces. So it repeats. It's called a periodic function. So it's a periodic function and it repeats. And notice how the wave that it creates, the peaks and the troughs are all the same distance apart. And that's the basis of the sine wave, which is a graph of sine theta, we say, or sine x. Cosine works very similarly, we'll see. So let's make note of that. So we've just been looking at y equals, we would say y equals sine x. Sometimes that's written as y equals sine theta. Depends on the variable, but it's the same basic type of wave or functional graph. The reason why it's sometimes called sine x is because we often write y versus x, don't we, when we graph? And we often call that the x-axis, and that one up there would be called the y-axis. But sometimes we look at it instead in terms of theta, because this angle, remember we were looking from the previous video, that was theta, wasn't it? And that changes, you see, so it's a variable. The other one, which you'll see is very similar, is y equals cos x, and it's a periodic wave as well. Now why aren't we talking about tan x? It's different, and I'll leave that for a later time. What we have here is another simulation, and it's from something called PHET, P-H-E-T, and we've got a unit circle here again too. Now we've got different coloured lines. You can see the radius arm in black there. We've got the x value in black and then the y value in green. The reason why that is that sine is illuminated. It's switched over to sine. Now remember from your previous video that sine was the same as the y, because remember if we've got theta there, the angle, we've got sine theta is opposite over hypotenuse. So sine theta is y over 1, which is just y. So remember that. Later when we do cos, remember cos is just adjacent over hypotenuse. And that would be, there's the adjacent, x over the hypotenuse 1, or just x. So that's from the previous video. So let's get this mark out the way, and let's have a look. We've basically got a bit of a chance to play with this, and you can see on your left there's some numbers changing. So theta, the angle, is 15, 16, 17. You can see that's theta basically, and see how sine theta is the y, and it's increasing. You might also be able to see as I move the radius arm around on the unit circle, you can see that there's movement along that graph there. So basically, like we saw just before, 0, see how they're using theta there. You could use an x, you'll see an x there. This is the y-axis because we're measuring sine of theta. So we're plotting all the sine values. So it's just like if somebody got their calculator, and for every degree you move, you find sine of that angle on the calculator, and they plotted it, and they would make this green wave. And you can see a few things there. We're at 0, 0 now on the graph, and the unit circle is in its resting spot. The radius arm goes up to 90, and what do we see? Sine theta is at a peak down here. And that's because, remember, the green value is at its highest value here. See? And then it starts to get lower. So you can see why it makes that shape. It's the measure of the green as your angle changes. Can you see on the unit circle too that the angles are overlapping? That's because I've done more than one period, more than one revolution. So going right around 360 degrees is one period for the sine wave. So 360 degrees. Let's have another look at that. So we've got, move this pen ink out of the way. Let's try that again, and just want to make sure we're rolling. We are, and basically you see this thing is going up the graph now. Next time it does that, it'll be over here. It's in the same spot in the second cycle. We call that a period. Okay, and when we're measuring theta in degrees, that's 360. You can see on the unit circle here it corresponds with one whole rotation, which is also 360 degrees. See that? So this one goes up to 2 rotations, so that's 2 lots of 360, 720, but it's doing the same thing. So it's called periodic. Okay, so you can see the angles now. I've put them on there. Okay, it's probably a bit too much, isn't it? So that's how it works, and we can see that there's a few special results there. Now we're going to switch it over to cos theta, which is very similar. Have a close look as I shift it over. So, and I use the word shift because did you notice that the graphs seem to be the same, but one is shifted compared to the other. It's a bit like cos is shifted a certain amount, a little bit to the left, but the shape is the same. And that's true. There's really nothing different about cos theta and sine theta except that there's a 90-degree difference between the two. So one's sine is 90 degrees ahead, its peak is 90 degrees ahead, cos's peak is 90 degrees before that. So why is that? Because you're measuring a different thing on the unit circle here. You're measuring how x changes. Now x is the blue on the unit circle is about to hit its minimum, and you can see that on the graph it's about to hit 0 on the y-axis. So when the blue disappears here, it'll be 0 length for that arrow, and it's on the 0. It's at y equals 0 here. Now it's negative. X is negative because it's gone left of the origin, and you can see the y value of cos theta is underneath, so it's negative as well. So it's the cos theta values are all negative there. Now it's at its most negative because the blue arrow is pointing at its longest amount in the negative direction, and it's only going to get shorter from there. See, the blue arrow gets shorter as I rotate it around. It's getting less negative, and you can see on the graph it's getting less negative, then it'll hit 0, and then the cos theta values will be positive again. So there's some interesting things there about that. So to summarize then, we need to write a few things down, and we notice that we have periodic functions. That means they repeat, and there's a symmetrical shape. Loosely, it can be called a wave. This applies to y equals sine theta and y equals cos theta. Sometimes y equals sine theta is known as y equals sine x, and y equals cos theta can be called y equals cos x. Tan is different. We're going to do tan some other time. A period is one full cycle, and that is, on these sort of graphs, it's 360 degrees because of the unit circle. And from the previous graph, the y values, they correspond with the sine graph, and the x values the cos graph. Did you notice that the graph had a maximum height and that was never exceeded? So the maximum height there on the graph corresponded for sine theta, when we get to the top there at 90 degrees, the maximum length of the green line. And when it comes around again, it's always the same. So again, so it never exceeds that. That is the maximum. There's one maximum, one value for the maximum, but there's lots of different places the maximum occurs. So it occurs regularly every 360 degrees, so every period. The troughs too, where it hits the bottom, they occur 360 degrees apart as well because of this unit circle. All corresponding sides do. So where it crosses the x-axis on the way up happens 360 degrees apart. On the way down too, it happens 360 degrees apart there. So that's true for sine and for cos. The places where the maxima are different. Cos starts at 0, 1, whereas sine starts at 0, 0. And that's because the blue line has its maximum here at the start, whereas it takes another 90 degrees for the green line to get to the maximum, and that's why they're apart by 90 degrees. But everything else about sine and cos is the same. The height, the maximum height there in this graph is called the amplitude. So basically that is the amplitude there for that particular graph, and for one based on a unit circle, that would be 1. So the amplitude is that there, and cos theta has the same amplitude. So final lot of notes then. We've got amplitude is basically the maximum distance from the resting point. Okay. is the maximum vertical distance from the rest position. Okay, so there's an introduction.